Hi, 7th graders. We're on lesson 12.3, which starts on page 643 in your textbook, and it is on experimental and theoretical probability. So our learning target today is I can find experimental and theoretical probabilities and use them to make predictions. So what is the difference between experimental and theoretical probability? Well, theoretical probability is what you expect to happen. So if you're if you're rolling dice or if you're picking marbles out of a bag or something along those lines, then theoretical probably is what we're expecting to happen. Experimental probability is what actually happens when you conduct the experiment. So theoretical probability would be what are our odds of rolling a 1 if we have a dice that has numbers 1 through 6. Experimental probability then would be we would take all of the times we rolled the dice and count how many times we actually got a 1, and that would be our probability. So let's do some problems. What is the theoretical probability of rolling a double 1 using 2 number cubes? So the probability of if we rolled 1 dice, the probability of rolling a 1 would be 1 out of 6, because one of the number sides of the dice is a 1, and there's 6 sides. So our bottom, our bottom number is the total number of options, I guess, that it could roll on or that could happen, and the top number is always, well, what are we trying to get? So since we're rolling a double 1, so that means we're rolling 2 number cubes or 2 dice, and so we would just multiply our probabilities together. So this would be our first dice, 1/6. Our second dice then would also be 1/6, because there's 1 chance of getting a 1 and there's 6 chances. So we would multiply them together. 1 times 1 is 1, 6 times 6 is 36. So you have a 1 out of 36 chance of getting 2 1s when you roll 2 dice. The graph shows, and oh, by the way, this is theoretical probability because this is before we're conducting the experiment, but we just know that our chances are 1 out of 6 to get a 1. If we rolled 2 dice 10 times and we happened to get double 1s 2 times, then it would throw off our theoretical probability, but that's just what we're expecting or what should happen. The graph shows the results of an experiment in which 2 number cubes were rolled. According to the experimental probability, is a sum of 12 likely to occur? So instead of sitting here and adding all of these up to tell us how many total rolls we did, I did that before. So there was 58 rolls or 58 sums. So we can see that 12 was rolled 1 time, because this line is 2 and it's halfway to that line. So our probability, our experimental probability is 1 out of 58. 58 tells us that we rolled it 58 times, and our 1 tells us that we got a sum of 12 1 time. So 1 out of 58 is not really that likely, so that tells us that it is not likely to get a sum of 12. We can also see that by looking at our data, and we can see that this is, well, it is the lowest one. So that would be the least likely. Okay, according to the experimental probability of this above again, which sum is most likely to occur? So we would look at the bar that is the tallest, because that means that we rolled it the most, and we can see that 8 is the tallest. And so then which sum is most likely to occur? And we would say 8. All right, 300 people were surveyed as to how they keep track of time. What is the experimental probability that a person uses his or her cell phone? So we know that this is experimental probability because we actually surveyed 300 people. We did the experiment, and this is our data. So when we have data and we do an actual experiment, then we know that that's experimental probability. Okay? So what is the experimental probability that a person uses his or her cell phone? So we're just looking at this number right here. So we would take 185, because that's how many people use their cell phone, over the total number of people, which is 300. So 185 over 300 would be our experimental probability. And if we take 185 and we divide it by 300, we can change it into a percent, and we would get about 62%. This just tells us, when we write it as a percent, it's easier for us to think about, oh, is that, now we can see, oh yeah, like a little more than half of people use their phone to tell time. What is the experimental probability that a person uses his or her watch to keep track of time? So instead we're going to look at this number, which is 57, and we're going to put it again over 300. And we can simplify this. The reason why I left this at 185 over 300 is because it's already simplified, but we can actually simplify this down to, because we can divide both by 3, and we would get 19 over 100, and we know that 19 over 100 then would be 19%. At a plant that manufactures light bulbs, an inspector finds that the probability that a light bulb is not defective is 8 out of 11, or you could say 8/11. Is this probability experimental or theoretical? Well, because he actually tested the light bulbs, and he figured out that 8 out of 11 light bulbs are not defective, then we know that this is experimental. If the company wants to have 10,000 non-defective light bulbs, how many light bulbs will they need to make? Well, 8 out of 11 are non-defective, as how they're saying. So we can actually set this up as a proportion. So we know that 8 out of 11 are not defective. So if we want to have 10,000, if we think way back to proportions, we set them up so we have the same units, I guess we could say, on the top and on the bottom. So these ones are non-defective on the top, and then our bottom would be, the total number tested. So then that would be our x. So then we would solve 8x equals 11 times 10,000. And we would get 8x equals 110,000, and then we would divide it by 8, and we get x equals 13,750. That should be a 7. So that tells us that they need to make 13,750 light bulbs in order for 10,000 to be non-defective. Okay, pause me really quick and do this last problem on your own. In a recent survey of 150 people, 18 responded that they were left-handed. If an additional 2,500 people are surveyed, how many would be expected to be left-handed? So we know that 18 out of 150 are left-handed. So we're going to set this up as a proportion again, just like the previous problem. So if 18 out of 150 are left-handed, then we know, so this time 2,500 people are surveyed. So that's going to be on our bottom because that's our total number surveyed. And before, remember, we had 18 out of 150 surveyed. So we have to match it up. So now we have X. And now we have 150X equals 18 times 2,500 equals 45,000. And then we're going to divide that by 150, and we get X equals 300. So that tells us that 300 out of 2,500 people surveyed, we would expect to be left-handed. So this 18 out of 150 is our experimental probability. Because we actually conducted the survey and it's our data and we used it. And so this is experimental. This X over 2,500, or actually 300 over 2,500, is our theoretical probability because we're using our data from 18 out of 150 and we are using it to predict how many out of 2,500. That's not to say that if we actually survey 2,500 people, that's not to say we might get 350, we might get 150, we might get 1,000. This is just what we're expecting to happen based on our small experimental probability, and our small experiment that we did. Okay? So it's important to recognize the difference. That we actually did the experiment over here, and this is what we're just expecting to happen. Okay? Yay for lefties, all 300 of us out of 2,500, because lefties rule. All right, have a good night. Make sure you go on to NICU and take your 12-3 NICU quiz.